Let's practice working on linear equations, but more specifically, we're going to practice writing linear equations when we're given a table. When writing each of our linear equations, we're going to follow the same pattern where we're always going to write the dependent variable first is equal to some rate or coefficient multiplied by an independent variable plus some starting number. For number one, let's start by identifying our independent and dependent variable values in the table. So x is independent and y is dependent. And let's take note of what our general form is going to be. So I'm just going to go ahead and put that over there. So what is the dependent value? That's just going to be y. So we're going to go write y is equal to, and this is going to be the same format for all the problems here. Then we have some rate multiplied by the independent variable. We don't know the rate right now, so let's leave that blank. So it's going to be something multiplied by the independent variable. That's going to be just x here. So let's go ahead and write x, so something times x. And then we're going to go ahead and add some starting number. We don't know what that starting number is just yet, so we're going to leave that blank. Now I'm going to be writing that starting number in yellow later on, so I'm going to highlight that with the same color so you can see. In each of these problems, I will write the coefficient or the rate in this green color and put that starting number over here in yellow. All right, so how do we find out this rate? Well, it's pretty straightforward. First, find out how quickly the dependent variable is changing and what sign it's going to have. So these are all increasing by 3, so we're going to put a +3 for the change. Then figure out how quickly these x values are changing, and it looks like these are also increasing by 3. It turns out if you take the change of these y values divided by the change of the x values, so +3 divided by +3, that's +1. That's going to be our rate or our coefficient for x. Now, what about to find the starting number? Well, the starting number, that's where we're going to see if we can find where we have x equals 0. So notice over here we have x equals 0. And when x is 0, then y is 8. So we're going to go ahead and add 8 over here. That's going to be our starting number, right? So this is our general form for our linear equation. What we're going to do is say, well, 1 times x, that's just going to be x, and use that identity property of multiplication and say that y would equal just 1x, or we can simplify it to say x, and then +8, which is our starting number. This would be our most simplified linear equation. Let's check out number 2 now. This would be our general equation, and these are our independent and dependent variable values. Let's go ahead and set this up. We're going to start off with a y equals, so y will equal something multiplied by x, so something multiplied by x, and we're always going to be adding something afterwards as well, technically, okay? We know that we're going to be adding some number at the end. I'm going to use that yellow again. And we're going to have some rate or some coefficient multiplying by x each time. Let's start by finding the rate here. So what we did in the last problem, we'll do similarly here. Let's check out how these y values are changing. Looks like they are increasing by 3. So let's go ahead and put a +3 on the side here. And it looks like our x values are also increasing by 3. So they're also adding 3 each time. Now to find this rate, we always take the change of these y values divided by the change of the x value. So 3 divided by 3. That's still going to be +1, so it just happens to be the same as in problem 1, just a coincidence. And to figure out what we're adding, notice how in the last problem we found something with a 0, but in this case we don't have that in our table, right? So actually, if we keep jumping to the left here, so if these are increasing by 3 as we go to the right, then these must be decreasing by 3 as we go to the left. So let's go ahead and do that. If we decrease this 12 by 3, that's going to be 9. If we decrease this 5 by 3, because they're jumping by 3s as well, that's going to be 2. If we decrease by 3, that's 6. Decrease by 3, that's going to be -1. Decrease by 3, that's going to be 3. Decrease by 3, that's -4. Decrease by 3, that's going to be 0. And decrease by 3, and that's going to be -7. Okay, so even though it's not in the table, technically you can go ahead and do this to see what it would be. So I'm just going ahead and write here that if you continue this, we'd have a 0 eventually, and we'd have a -7 eventually. So if you wanted to know what we're adding or subtracting, that value here would be -7. So let's go ahead and put a -7 as that starting number. And let's simplify this. So 1 times x by the identity property is just x. So it's going to be y is equal to x, or 1x. And instead of writing plus a -7, we can just write -7. Okay, so that would be our linear equation. So all the x values take away 7 would equal all of their corresponding y values. Here's number 3. All right, number 3, we have our variables identified and our general form for our linear equation. Let's go and see if we can find out that rate first. Let's go and do that, and we'll deal with the starting number afterwards. So let's go and see how are these y values changing. Looks like we're going +2, +2, +2, and +2. So we have a change of +2. And it looks like over here we have +2, +2, +2, and +2. So a +2 over a +2. Let's take this one and divide by this one. That's going to be a +1. So it looks like we're going to go ahead and put a +1 for a rate or our coefficient. And then for our starting number, let's see what that's going to be. Remember, for our starting number, we are looking to see where x is 0 if that's in our table. Looks like we are given that. So when x is 0, y is -5. So we can go ahead and say that this starting number is going to be a -5 here. Okay, so let's go ahead and simplify this. 1 times x by the identity property is just going to be x. So we're going to get y is equal to 1x, or just x. And then instead of adding a -5, we can simplify this and just write we are subtracting 5. So if you take all of our x values and subtract 5, you'll get each of the y values in this problem. Here's number 4. In number 4, let's go ahead and start by finding the rate here. So it looks like we are increasing by 10 again, add another 10 and add another 10. So it's changing by 10 here, right? Now what about the x values? Well, this is increasing by +5, +5, +5, and +5. So that's a change of 5. So by taking this +10 and dividing by +5, 10 divided by 5 is 2. So we're going to have a coefficient or a rate of 2 here. Now that we have the rate, let's go ahead and see about that starting number. Now remember, in the last few problems, we were looking for where x is 0, but it doesn't look like we have any x values of 0 here. And if you try to jump down by 5, you're going to end up at -2, and jump down by 10 following the pattern will be at -4. So it looks like we're going to miss 0. If this ever happens, what you can do is you can just take a look at the rule that you have, which so far is 2 times x. And if you go ahead and multiply 3 by 2, you do get 6. Multiply 8 by 2 is 16. 13 by 2 is 26. Multiplying each of these numbers by 2, you already get the y value. So that means that you have to add nothing here. Now, if it was off by a certain amount, then the distance between your number and the number in the y values, that's what you would either add or subtract. So if it was higher, then you should add. If it was lower, you should subtract. Okay, so in this case, when we multiply, we get exactly what we want, so we don't have to worry about that. But our linear equation here is going to be y is equal to, and instead of writing 2 times x like that, we're going to write 2x without that dot, and we don't have to write the +0 by the identity property of addition. Here's number 5. Okay, so here we have everything labeled. Let's start with finding the rate first. So let's see how these y values are changing. It looks like they are increasing by +1 each time. They're getting bigger, so +1. And these independent variable values, or these x values, looks like these are increasing by 3 each time. So it's going to be +3, okay? So to find the rate, that's going to be +1 divided by +3. That's going to be 1/3. So that's going to be the rate here. It's going to be a fraction. Okay. Now, what about the starting number? Well, to find the starting number, we're looking for where x is equal to 0. Doesn't look like x is 0 in any of these, but it looks like we could also continue the pattern here. So if these are going by +3 as we go to the right, then as we go to the left, it's going to be -3, so that's 9. And if we lose, or go to the left rather, that's going to be 3. If we go down by 3, that's going to be 6. Go down by 1, that's going to be 2. Go down by 3, that's going to be 3. Go down by 1, that's going to be 1. Go down by 3, that's finally 0, and to go down by 1, that's going to be 1. So it looks like when x is 0, y would also be 0 here. So we know that the starting number is going to be 0. So we're going to go ahead and write here that eventually we'd have a 0, and we'd also have a 0 for y at the same time. So I'm just going to go ahead and say that if you continued that pattern, that's what we would know it would be. Also, you can also see that if you take 1/3 of each of the x values, if you take 1/3 of 12, that's 4, 1/3 of 15, it's 5, so on and so forth. You don't have to add or subtract anything. So this happens to be 0. And so you can simplify your linear equation to say y is equal to just 1/3 times x, or 1/3 x. This would be our linear equation here. Here's number 6. Let me scroll up a little bit more. All right, so here we have everything labeled. Let's start with finding the rate. So for the rate, let's figure out the change of the y. So this is +3, +3, +3, and +3. So that's the change of the y values. Now the x's look like they are increasing, but by 4 rather. So it's +4, +4, +4. So that's going to be the change of the x value. So to find this rate, what we're going to do is we're going to take this 3 and divide it by 4. That's just going to be 3/4. So we know that's going to be our coefficient or the rate here. Okay. Now, what about the starting number? Well, for the starting number, we need to find when x is 0. Okay, so notice how these are all going up by 4s as you go to the right. So as you go to the left, we're going to decrease by 4. So same thing, if we're going to the right and we add 3, then when we go to the left, we're going to subtract 3. So going to the left, this is going to be 4. Going to the left, this is going to be 3. Going to the left again, that's going to be 0. And going to the left, that's going to be 0. So looks like our value here is going to be 0 and 0. So when x is 0, y would be 0, would be that value in the table if you extended it, which means our starting number is going to be 0. So simplifying our linear equation, we can write y is equal to, and we can write 3/4 multiplied by x, or just 3/4 x. We don't have to add or subtract anything, right? So it turns out if you take all of these x values and you multiply them just by 3/4, you'll get each of these y values. You don't have to add or subtract at all. For number 7, let's find the rate here. The rate, let's go ahead and see the change. So for our y's, it looks like these are decreasing by 1 each time. So let's say -1. And it looks like for our x's, they are increasing, but by a different number, they're increasing by 3 each time. So for our rate, it's going to be -1 divided by a +3, and that's just going to be -1/3. That's going to be our coefficient. Okay, now if you go ahead and do that, then we want to find out maybe what our starting number is. Our starting number is when we can find x to be 0, which I see right over here. So when x is 0, y is also 0, so that means we do not have to add or subtract anything here. So simplifying this linear equation, we can write y is equal to, and we have -1/3 times x, or just -1/3 x, where -1/3 is the coefficient, and we can drop that plus 0. So looks like if you take -1/3 of each of these x values, you will get each of these y values. You don't need to add or subtract. Here's number 8. Alrighty, so let's go ahead and see if we can figure out our rate first. Let's see the change. So this is +2, +2, +2, and +2. So we know the rate is going to have a change in terms of the y values of +2, and these x's are doing +1, +1, +1, and +1. So we're trying to figure out the rate or the coefficient. It's going to be +2 divided by +1, which is just going to be 2. So our rate here is going to be 2. Okay. Now what about the starting number? Let's see if we can find a column where x is 0. Looks like x is 0 here. So if x is 0, then y is 5. So our starting number must be 5. So simplifying and writing our linear equation, we could write y is equal to, and we can write 2 times x, or just 2x rather, and then +5. This would be our most simplified linear equation. So if you take all these x values and you multiply them by 2, and then you add 5, you'll get each of these y values. For number 9, let's go ahead and start by finding the rate here. So let's find out the change of the dependent variable values, or the y values. So this looks like it's being added by 9, +9, +9, and +9. So each of these are adding 9. As for the x values, this looks like it's a +3, +3, +3, and +3. So it's increasing by 9 for the y's and by 3's for the x's. So 9 divided by 3 is going to be 3. So it looks like we're going to triple all the x values. And let's see if we can find our starting value. Let's see if we have a 0 in the table. Looks like we do. So this is a 0 and a -4. So that means that our starting value must be -4. Okay, so let's go ahead and see if we can simplify this. So we have y is equal to, and then 3 times x here, that's just going to be 3x. So we can kind of squash those together and write that 3 as a coefficient. And then instead of adding a -4, we can just subtract 4. So we have y is equal to 3x minus 4. So if we take all these x values and we triple all of them, and then take away 4, we will get all of these y values. All right, let's check out number 10. All right, for number 10, let's start by finding the rate. So it looks like these y values are increasing by 2 each time we go across. So that's going to be the change there. And then for these x values, these are changing by, looks like 4. So let's go ahead and see what this is going to be. So to find the rate, we take the change of y divided by the change of x. So 2 divided by 4 is the same thing as 1/2 if you simplify them by their GCF. Okay, so that's going to be our coefficient. And then we're looking for our starting number, and that's where if we have an x value of 0. So it looks like that happens right over here. When x is 0, y is 3, so we know our starting number is going to be 3. So simplifying this linear equation, we're going to get y is equal to 1/2 times x, or just 1/2 x. And then we would go ahead and add 3 on afterwards. Okay, so what this means is if you take half of each of these x values and then you add 3 to them, you'll always get these y values. Here's number 11. All right, so here we have everything labeled. Let's start by finding our rate first, or our coefficient for x, okay, the rate of change here. And so let's see, the y's are changing, it looks like, by +1 each time. They're increasing by 1. And what about the x's? It looks like they are increasing by 3, by 3, by 3, and by 3. So if we find the ratio of their vertical change to horizontal change, 1 divided by 3, that's just going to be 1/3. So that's going to be the coefficient for x. And then for our starting number, let's see if we have an x number of 0. Looks like we do right over here. So when x is 0, y is -4. So that means our starting number is going to be -4. Okay. Simplifying this a bit, we can rewrite this and say y is equal to, instead of writing 1/3 times x, we should be able to just write y is equal to 1/3 x. And instead of writing plus a -4, we can simplify that and just write -4. That's the same thing with less writing. What does that mean? That means that's our linear equation, or our rule. So if we take 1/3 of all of these x values and then take away 4 from them, we will get each of these y values. All right, so here's number 12, and let's finish up with just a couple more. All right, for number 12, let's start by finding the rate here. So the rate is going to be the ratio of the changes. So looks like this is going to be +4, but this is going to be +6, right? So if we have +6 and +4, that's interesting. So 6 over 4, that's going to be the same thing as 3 over 2, right? Now, if you look over here, these are all changing by 2. So +2, +2, +2. This is +3, +3, +3. So if you think about it as +6 and +4, or +3 and +2, is that the same ratio? Well, yeah, I would say that 6 divided by 4 is the same thing as 3 divided by 2 in terms of their values. So 3 divided by 2 is just going to be 3/2, or 3 over 2 as an improper fraction. So even though they're not jumping by the same amount specifically, they have the same ratio nonetheless. When you simplify, you get the same thing. Now, what about that starting number? The starting number, we're looking for where x is 0, and this table is nice enough to have that. So if x is 0, y is +7, so we know that's going to be our starting number. So simplifying this, our linear equation is going to be y is equal to, and our coefficient is 3/2, so 3 over 2 multiplied by x, and then +7. So that's our linear equation. Here's number 13. For number 13, we have everything labeled here. Let's go about solving this rate. So if we go ahead and start with that, we can see here that these y values are changing by +1 consistently across. So that's +1 all the way. And then our y values looks like they are increasing by 2 each time. So +2, +2, +2, +2. So if we want to find that rate, it's going to be this 1 divided by 2, +1 divided by +2, and that's going to be half, okay? And so half of x. And then for our starting number, let's see if we can find somewhere where x is 0. I'm noticing here x is 0, and when that happens, y is 8. So we're going to go ahead and put an 8 over here for our starting number. So our linear equation is y is equal to, and it's going to be half of whatever x is, so 1/2 x, and then +8 afterwards. Okay, so looks like what that equation means is if you take half of all these x values and then you add 8 to them, we will get all of these y values. All right, one final one. Let's check out number 14. Okay, so let's go ahead and start by finding the rate just like we did for all the other practice problems here. And it looks like these y values are going down by 1 each time. Okay, so going down by 1, let's put a -1. And these x values here are increasing, and it looks like they're increasing by 4 every single time, so that's +4. Okay, so to find this rate, it's going to be -1 divided by +4, and that's just going to be -1/4, or -1/4. Okay, now that's going to be the rate that we have here. Now what about the starting number? Do we see an x value of 0? Looks like we do right over here, which is really nice. That means if x is 0, y is -3, so our starting number will be -3. Okay, simplifying this a bit, we can write y is equal to, and it's going to be a negative 1/4 as a coefficient multiplied by x, so negative 1/4 x. And instead of writing plus negative 3, we can just write minus 3. So what does this mean? It means that if we take all of these x values and multiply them by negative 1/4, and then afterwards we go ahead and subtract 3, we will always get all of these y values that we have in the table that correspond with them. All right, so there you have 14 different practice problems where we take a table that represents a linear relationship, and we can use that information to find out the rate or the coefficient, as well as the starting number, and then write a linear equation. Sure, you can try guessing and checking, and there are other strategies as well, but in this particular video, hopefully you felt better about using this strategy that we practiced. If you found the video helpful, please consider giving it a thumbs up and sharing with a friend if you think they might find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.